Hi Nightscapers, welcome back. In the last unit we set up our cameras, so now we're ready to start making exposures. Before we worry about precisely focusing, we should set the focus to infinity and take a test shot with some initial exposure settings. The cool thing about the night sky is that the stars are always the same brightness, so if there are no other light sources such as light pollution or moonlight, we can usually use the same exposure every time. Start with one of the exposure settings listed here and then adjust accordingly. Pick the combination with the lowest f number that your lens can do. If you don't have the option to pick an ISO high enough to match one of these exposure settings, just set it as close as your camera will allow. For example, my Canon T2i with an 18mm f3.5 lens can only go as high as ISO 6400, so I'll set my exposure to f3.5, ISO 6400, and 30 seconds for now. These settings should work about 95% of the time for your first exposure if you're shooting in dark sky conditions. The only thing that may affect the exposure is the amount of light pollution or moonlight. I start with these numbers every single time I shoot astrophotos of the Milky Way, and then I make small adjustments as necessary. Let's briefly talk about each of these settings and why we pick them. For the aperture f number, we want to start with the lowest f number possible for our particular lens. The lower the f number, the larger the opening of the lens, and the more light the lens can gather at any period of time. Common minimum f numbers for lenses are f1.4, f2.0, f2.8, f4.0, and f5.6. Each higher f number in this sequence has half the light gathering area of the previous one. That means that an f1.4 lens gathers 8 times more light than an f4.0 lens of the same focal length. Since we're particularly concerned with collecting as much light as possible in these dark conditions, we want to start with the lowest f number possible. Photographers usually call this shooting wide open, as opposed to shooting stop down. The only reason to stop down to a higher f number is if your astrophoto is showing overly blurry edges. When you use low f numbers, some lower quality lenses may show blurry corners due to imperfections in the lens design, usually called spherical or chromatic aberration. If this bothers you, you can usually stop down to the next highest f number to reduce the effect of aberration, but this comes at the expense of light gathering capability, and you usually need to compensate by increasing your ISO. ISO is how much gain or amplification your camera uses to boost the signal of the image. Higher ISOs allow us to see darker features in the night sky, but at the expense of higher noise. Because the light of the stars is relatively low, we almost always need to use an ISO above ISO 1600, and often as high as ISO 12800. This usually means that we'll need to tolerate relatively high amounts of noise and grain in our astrophotography. If your images are too noisy to the point of being unusable, or if the levels of light pollution or moonlight are bright enough that your image is overexposing, you may need to reduce your ISO just a bit. Keep in mind that noise can be corrected with the long exposure noise reduction feature in your camera, and also in post-processing with photo editors like Adobe Photoshop Lightroom. Finally, we should start with a 30-second shutter speed. 30 seconds is typically the longest shutter speed that a digital SLR will allow us to use without needing to use the bulb function or an intervalometer. Just like a low f number, a long shutter speed allows the camera to gather more light in these dark conditions. 30 seconds is also just about the longest shutter speed that we can use with our wide-angle lens before we start to see star trails in our image. Star trails are caused by the rotation of the Earth. You can check to see how much star trailing you're getting by using the magnify function on your camera when you play back your photo. If the stars are trailing too much, just reduce the shutter speed a bit. Once you've made any necessary adjustments and have decided on the exposure settings that seem to work best for you, you should be able to use the same exact settings for the duration of the night until the light changes due to something like the moonrise or sunrise. For more detailed guidelines for adjusting your shutter speed, aperture, and ISO, check out the written lessons in this unit. After you take your first exposure, you should make sure the stars are in focus by using the magnify function while playing back the image. There are a few methods to help us focus more accurately in the dark. The first method is to use live view mode and center your frame on one of the brightest stars in the sky. Use the magnify function and adjust your focus ring until the star is a small bright pinpoint. If you're having trouble seeing even the brightest stars on the LCD, you can also try focusing on a distant artificial light source, like a distant building or town, or even on a headlamp placed about 100 feet away. If you're using an older model digital SLR that doesn't have live view, you'll need to use trial and error to set your focus. Take an initial test shot, and then adjust your focus for the next consecutive shot until you're convinced that you've achieved sharp focus. These focusing methods require a bit of patience, but once you have the focus set, you shouldn't need to adjust it again, unless you accidentally bump the focusing ring. One helpful trick is to use a piece of masking tape or gaffer's tape on the focusing ring to reduce the chance of bumping it. Now that you've determined your exposure settings for the night and have your focus set, you're free to start experimenting with different compositions. Check out the next unit for more tips on composition and ideas for your nightscape self-portrait.